Hey there, in this video we are going to look at dividing rational expressions and we're going to use the technique of multiplying by the reciprocal to do that. Now, dividing rational expressions is going to be very much connected to multiplying rational expressions. And it's going to be easiest done using the concept that dividing is equivalent to multiplying by the reciprocal. Or if you want to write it with symbols here, if you have a over b divided by c over d, this is going to be the same as having a over b multiplied by d over c. Or in other words, dividing by that fraction is equivalent to multiplying by the reciprocal of that fraction. All right, let's look at some examples. That division we're going to write right away as 40x squared over x plus 6 multiplied by, instead of dividing by that, we're going to multiply by the reciprocal. We're going to put the 3x plus 18 on the top and the 24x to the 6th. We don't need to do much factoring here, but we need to do a little bit of factoring here. This is something that can be factored. This and this are single terms, so they're already in a form that we can use. This is something that can't be factored any further. So I'm going to write that 3x plus 18 as 3x plus 6. And then I'll quickly write the rest of it. Then we can get rid of some things that we have in common here, like this x plus 6 divides to 1, like this 3 and this 24 can be a 1 and an 8. Like this x squared and this x to the 6 is going to leave me with x to the 4th down there. And this 40 and this 8 actually are going to leave me with a 5 up there and a 1 down here. Now I've gotten rid of everything I can get rid of there, so I can just write my result that's left over, which is actually fairly simple. It's just 5 over x to the 4th. All right, that's the simplest version of that original expression that we started with. Let's look at this second one here. We will change this to multiplying by the reciprocal. I'll do that really quickly here. And then, of course, we want to write it in factored form to see if we can reduce it at all before we multiply it out. This top thing here, we can write that as x squared times x minus 3. The denominator of that one we can write as two binomials, x plus 4, x minus 1. This over here we can actually write as x times x plus 4. And the bottom we can write as 2, common factor of 2, x minus 3. So there's actually several common factors we can get rid of there. X minus 3, x minus 3, x plus 4, x plus 4. Beyond that, though, I don't think there's anything left we can get rid of, because we have x squared and x on the top, and there are no x factors on the bottom. So at this point, I can just write my result x cubed, because we have x squared times x, and we have a 2 and an x minus 1. That expression right there is equivalent to that which we started with. All right, let's try the two bottom ones. First of all, quickly change it to multiplying by the reciprocal. Next, do some factoring. This top thing here, x to the 4th minus 16 is actually a difference of squares. Even though it looks a little different than the ones we've seen before, you can write it as x squared plus 4 and x squared minus 4. The bottom of that, x squared plus x minus 6, can be x plus 3, x minus 2. On this side, x plus 3 we have there, and x squared plus 4 can't be factored anymore because it's not a difference of squares, it's a sum of squares which cannot be factored. Now, at this point, we have one thing left. We can actually factor this slightly more here. That is actually going to be equivalent to x plus 2, x minus 2. Now, I'm going to rewrite all the rest of it really fast here. Now when we have that completely factored, we can look at reducing that. So what we have in common, we actually have this x minus 2, this x minus 2. We have an x plus 3 over there. We actually have this factor, x squared plus 4. I can cancel it with that because it's exactly the same. So cross that off. And all I have left is this x plus 2. So that entire thing is actually equal to x plus 2. All right, let's look at the last one here. This is divided by something that has no denominator, but just like if you were dividing by, say, 4, you could change it to multiplying by 1/4. We can do the same thing here. We can make this 2x plus 3, x plus 3 on the bottom. We can change it to multiplying by 1 over 9 minus 4x squared. Now our next step is to make sure everything's written in factored form. Each of these is already as factors as it can be. They don't have any common factors. We can't break it up into binomials. So I'm just going to leave it as is. This second thing though, this is a difference of squares. So how I'm going to write it is actually, I'm going to write it as just 3 plus 2x, 3 minus 2x. If you felt like you wanted the x squared to be first, so that it looks a little more kind of the normal order that terms are written in, you could factor out a -1. You could write this as -1 times -9 plus 4x squared, or in other words, -1 times 4x squared minus 9. If you like that better, if you found that easier to factor, you can factor out a -1. I'm just going to write it like this, backwards like that, for this time. And then when I look to cancel some things, the only thing that I have in common is this 2 plus 3x and 3 plus 2x. Now, they're written right now in the reverse order to each other, but since this is a plus in between here, these are the same thing. Addition, it doesn't matter what order you have things in addition. So this and this are identical. I can just cross them off. They divide to 1. They don't divide to -1 as we've seen before with opposites. They divide to 1. So that actually is just going to be 1 over x plus 3 times 3 minus 2x. Or if you had factored out a -1 like we did up here, you would end up on the bottom here instead, you'd have -1 and you'd have 2x plus 3, 2x minus 3, and you'd get rid of those 2x plus 3's. So you'd likely have this written as 1 over x plus 3, 2x minus 3, but you'd have a negative in there somewhere because you factored out that -1. Either one of those is fine, either way there. All right? So that's a look at dividing rational expressions.